Hi everyone, Mr. Lennie here from Impact Circle, and in this video, we will be going through the 9 laws of indices. For the first law, let's take a look at this example. What happens when we have 3 to the power of 3 multiplied by 3 to the power of 2? The meaning of 3 to the power of 3 is 3 times 3 times 3. And the meaning of 3 to the power of 2 is 3 times 3. And these two things are actually multiplied together. So do you see that we now have an expression where all the numbers are multiplied together? How many copies of 3 do you have? We have 3 copies plus 2 copies, giving us a total of 5 copies of 3. And therefore, we can see that 3 to the power of 3 multiplied by 3 to the power of 2 gives you 3 to the power of 3 plus 2. And this is our first law of indices. A to the power of m multiplied by a to the power of n gives you a to the power of m plus n. For our second law, it's very similar to this one. Instead of times or multiply, instead it will be divide. What do you think will happen when we have a to the power of n divided by a to the power of n? Some of you may have guessed correctly. The answer is a to the power of m minus n. Why is this so? Let's take a look. Okay, if instead of having 3 to the power of 3 multiplied by 3 to the power of 2, what happens if we change this to divide instead? We will get a fraction where on top you will have 3 times 3 times 3, and at the bottom you have 3 times 3. And as you know, when we have a fraction with factors on top and below, we can actually cancel the same factors on top and below. So we will cancel 1 on top, 1 below, 1 more on top, and 1 more below. And what are we left with? We are left with 1 copy of 3 on top. And you can see that 3 to the power of 3 divided by 3 to the power of 2 will give us 3 to the power of 3 minus 2, which is 3 to the power of 1. Okay? And this shows you how this second law of indices work. Yeah. All right, let's move on. How about the next law? The next law of indices goes like this. A to the power of m to the power of n is equal to a to the power of m times n. Let's take a look at a simple example. Let's say we have 5 to the power of 3, and we take the whole thing to the power of 2. This actually means that we have 2 copies of 5 to the power of 3. And these 2 copies are multiplied together. Each of these 2 copies are then further split into 3 copies each. 5 times 5 times 5. And on this side, another 5 times 5 times 5. And these 2 sets of 3 are multiplied together. So how many copies of 3 do we have then? We have 3 here. We have another 3 here, giving us a total of 6 copies of 3. And you can see that this is actually 5 to the power of 6. For our next law, we're going to explore 0 powers, the power of 0. So the law goes a to the power of 0 equals to 1. Why is this so? Let's borrow the previous law to work this out. The previous law says that a to the power of m divided by a to the power of n equals to a to the power of m minus n. What happens when both of these powers are the same? Let's take one example. For example, a to the power of 3 divided by a to the power of 3. On the right-hand side, this will give us a to the power of 3 minus 3, which is a to the power of 0. On the left-hand side, you have two numbers dividing, and both numbers are the same. What happens when you have one number divided by itself? Yes, you always get the result of 1. And this is how we show the third law of indices, which is a to the power of 0 is 1. Anything, you can take 5 to the power of 0, 1 million to the power of 0, and it will always be 1. Next, let's take a look at negative powers, shall we? For this example, we're going to use the previous two laws, right? Which is a to the power of m divided by a to the power of n equals to a to the power of m minus n. What happens when the first one is a to the power of 0 and the second one is a to the power of 3, for example? The right-hand side will be a to the power of 0 minus 3, which will give us a to the power of negative 3. So what is a to the power of negative 3? Let's take a look at the left side. A to the power of 0 gives us 1. And do you see it? This shows that a to the power of negative 3 is actually 1 divided by a to the power of 3. Right? And now this shows us that the general rule is a to the power of negative m will be equal to 1 over a to the power of n. So remember, having a negative power doesn't necessarily mean that your number is negative. It just tells you that you must flip the numerator and the denominator. Next law, let's explore fractional powers. Let's try a to the power of 1 over n. Let's give a simple example. Let's take n to be equal to 2. This will give us a to the power of half. What happens when you take a to the power of half times a to the power of half? Using the first law of indices, this will give us a to the power of half plus half, which is a to the power of 1. Can you now see what a to the power of half is? We have the same number multiplied by itself, giving you the result of a. This means that each of these blanks has to be the square root of a. The square root of a. Yeah? Let's try another example where n is equal to 3. So similarly, a to the power of 1/3 times a to the power of 1/3 times a to the power of 1/3 is equal to a to the power of 1. And again, what does it mean to have 3 numbers all the same multiplied together to give you a? Each of these blanks has to be the cube root of a. The cube root of a. This shows you that this number in the denominator actually means a root. It's not so much a power, but it's more like a root. So if you have a 5 in the denominator, that will be the fifth root. If you have a 4 in the denominator, that will be the fourth root. Generally speaking, it will give us this. When we have a fraction power where there's a numerator and a denominator, the top or the numerator will give us the power. The bottom or the denominator will give us the root. And we can choose to either root first or power first. Let's take a simple example. If we have 8 to the power of 2 over 3, what does this mean? This will mean that we will take 8 squared and then we will cube root the result. But we can also do it another way, which is to do the cube root first and then square the result. Both of these ways are exactly the same. But which should we choose? As I always tell my other students, we always try to make the number smaller because before we make it bigger, because this makes it easier to work out. So let's make the number smaller. Let's do the root first. So what is the cube root of 8? That gives us 2. And if we take that to the power of 2, that will be 4. So this is how we work out fractional powers. We have 2 more laws of indices, right? And this is where we have indices with the same, or rather the same power, yeah? So let's try a to the power of m times b to the power of m. What does this mean? Let's give a simple example to take a look. Let's try 5 to the power of 3 times 3 to the power of 3. This gives us 5 times 5 times 5 and 3 times 3 times 3, with these two things being multiplied together. You can see that all the signs here are multiplication, and we can actually shift the terms around to give you 5 times 3, 5 times 3, and 5 times 3, all multiplied together. And this will be the same as having 3 copies of 5 times 3. Okay, so what does this tell us? This tells us that a to the power of m times b to the power of m will give you a times b all to the power of m. Similarly, for our final law, we have a to the power of m divided by b to the power of m. So a to the power of m divided by b to the power of m. And in the same way, this will give us a divided by b to the power of m. Or we can write it this way, a to the power of a over b all to the power of m. So with that, we have gone through all 9 laws of indices. To end this video, let's run through them again so that we can remember what they are. Our first law, a to the power of m multiplied by a to the power of n gives us a to the power of m plus n. And the partner to this law is division. A to the power of m divided by a to the power of n, which will give us a to the power of m minus n. Next, we will have the power of the power, a to the power of m all to the power of n, and this will give us a to the power of m times n. Or another way to write it will be a to the power of mn. Next up, we have the zero power. Anything to the power of 0 is always 1. The negative power, a to the power of negative m, gives you the reciprocal, or 1 over a to the power of m. Fraction powers, we have the simple one first. A to the power of 1 over n will be the nth root of a. A to the power of m over n will be the nth root of a to the power of m. And finally, our last two will be a to the power of m multiplied by b to the power of m, where the powers are the same. This will be equal to a times b all to the power of m. And finally, in a similar manner, a to the power of m divided by b to the power of m is equal to a divided by b all to the power of m. So there you have it. With that, we have the 9 laws of indices. Have a nice day and happy practicing. Bye.